So we have seen the range function which produces a sequence of values. So in general, if we write range I comma j, we get the sequence I plus 1 up to j minus 1. Now quite often we want to start with 0. So if you give only one argument, if you just write range j, this is seen as the upper bound and the lower bound is 0. This is like a slice where if we don't write the first argument of a slice, if we write for instance L colon n, then it will run from 0 to n minus 1. So in the same way, if we just write range j, automatically we will get 0, 1 up to j minus 1. Often we may want to generate a sequence where we skip by a value other than 1. So we want a kind of arithmetic progression, if you are familiar with that. So we want I plus k, I plus 2k and so on. So we do this by giving a third argument. So the third argument, if we give it to range, tells the range function to skip every k items. So we have I, then we go directly to I plus k. So implicitly, if we don't say anything, it's like we put a 1 here, right? So the default value is 1, I plus 1 and so on. Now how far does this go? Well, we want to go until we reach normally j minus 1. In general, we don't want to cross j. So what we will do is we will get I plus nk for the largest n such that I plus nk is smaller than j. But if I go one more step, if I go to I plus n plus 1 times k, then I will cross j. Okay? So if we have a step, then we will keep going until we cross j and we will stop at the last value that is before j. Having a step also allows us to count down. All we have to do is make the step negative. So if we say I comma j comma minus 1, then provided we start with a value which is bigger than the final value, we will start with I, produce I minus 1, I minus 2 and so on, and we will stop with j plus 1. So the general rule for the range function is that you start with I and you increment or decrement if k is negative in steps of k such that you keep going as far as possible without crossing j. So in particular, what this means is that if you're going forwards, if you're crossing, if you're positive, if your increment is positive, then if you start with a value which is too large, then you will generate the empty sequence because you can't even generate I, because if I itself is bigger than j or equal to j, then that would not be allowed. Conversely, in the negative direction, what happens is that if we start with a value which is smaller than the target value, we are already below j, and so we can't proceed. So we get an empty sequence. So this idea about not crossing j, okay, so it's the same as saying stop smaller than j, because if we're going in the negative direction, we want to stop at a value larger than j. So you can think of it as before, and before means different things depending on whether you're going forwards or backwards. So just to see an example, suppose we want to have a range which starts from 12 and whose limit is 1, but the increment is minus 3. So we will start with 12 and then we'll go to 9, and then we'll go to 6, then we'll go to 3. And if we were to go one more step, we would go to 0. But since 0 crosses 1 in the negative direction, we would stop at 3 itself. We wouldn't cross over to 0. So it's often confusing to new programmers that range I comma j is actually from I to j minus 1 and not to j itself. So there is no real reason why it should be this way. It's just a convenience, and the main convenience is that this makes it easier to process lists. So remember that if we have a list of length n, the positions in the list are numbered 0, 1 up to n minus 1. So very often what we want to do is range over the indices from 0 to n minus 1. And if we don't know n in advance, we get it using the length function. So we would like to range from 0 to the length of the list. So if the range is defined as it is now, where the actual values stop 1 less than the upper limit, then range 0, length of L will produce the current range of valid indices. If on the other hand, it did what we perhaps think is more natural and it will do I plus 1 up to j, okay, if this were the case, then every time when we wanted to actually range over the list positions, we would have to go from 0 to length of L minus 1. So we have to awkwardly say minus 1 every time, just to remind ourselves that the position stop 1 short. So it is mainly for this convenience that we can freely use the length of the list as the upper bound, that the range stops at j minus 1. As I said, this is not required. You could easily define a range function which does the natural thing, which is I plus 1 up to j, but then you have to keep remembering to put a minus 1 whenever you want the indices to stop at the correct place. So a range is a sequence, and it's tempting to think of range as a list. So we saw that for comes in two flavors. We can either say for I in a list, or we can say for I in range something. So range 0 to 10 generates the sequence 0, 1 up to 9. Right? So is this the same as saying for I in the list 0, 1, 2, 3, 4 up to 9? So in other words, if we ask Python the following comparison, is range 0, 10 equal to the list 0, 1, 2, 3 up to 9, then the question is the result of this comparison true or false? So here we've encountered a difference between Python 2 and Python 3. So in Python 2, the output of range is in fact a list. So if you run this equality check in Python 2, the answer would be true. But for us in Python 3, range is not a list. Okay? So range produces something which is a sequence of values which can be used in contexts like a for, but technically the range is not a list. We can't manipulate the output of range the way we manipulate a list. Now it is possible to use range to generate a list using the function list. Okay, so the name of the function is actually list. So what we would do, for example, is give the range as an argument to list. So the sequence produced by range will be converted to a list. So if I want the list 0 to 4, I can say give me the range 0 up to 5. Remember, the range will stop at 4 because 5 is the upper bound. And this sequence will be converted to a list by the function list. So this is an example of a type conversion. We are converting the sequence generated by range, which we said is not a list, into a list by saying make it a list. So the function list takes something and makes it a list if it is possible to make it a list. If it is something which doesn't make sense, it will not give you a valid value. Now this is a general feature, so we can use the names that Python internally uses for types also as functions to convert one type to another. For example, if we have the number 78 and we want to think of it as a string, then the function str will take its argument and convert it to a string. So str will take any value and convert it to a string representing that value. This happens implicitly, for instance, as we will see, when we want to display a value using a print function. So what print will do is take a value, convert it to a string, and only strings can actually be displayed because strings are text. What we see on the screen or when we print out something is text. So str is implicitly used very often. Sometimes we want to do the reverse. We want to take a string and convert it to a value. So for instance, if a string consists only of digits, then we should get a value corresponding to that string. So if we give it the string 321, then it should give us back the integer 321. So the value, remember the name of the function is the same as the name of the type to which you want the conversion to be done. So we want to take a string and make it into an int. So we use the name int. Now in all these things, the function will not produce a valid value if it cannot do so. So if I give the function int a string which does not represent a number, then it will just give me an error. So long as the type conversion is possible, it will do it. If it doesn't, it returns an error. We will see later on that actually the fact that you get an error is not a disaster. There are ways within Python to recover from an error or to check what error it is and proceed accordingly. So to summarize, what we have seen is that our simple notion of range from I to j has some variants. In particular, if we don't give it a starting point, we just give it one value, it's interpreted as an upper bound. So range n is a short way of writing 0, 1, 2 up to n minus 1. Also, we can use a third argument, which is a step, in order to produce sequences which proceed in steps I plus k, I plus 2k and so on. And in particular, if k is a negative step, then we can produce decreasing sequences. And the last thing to remember is, though range produces a sequence which can be used exactly like a list in things like for, in Python 3, a range is not a list. So if we want to get a list from a range output, we must use this type conversion called list. So in general, we can use type names to convert from one type to another type, provided the value we are converting is compatible with the type we are trying to convert to.